Hello everyone, this is Kanfar here. Another demonstration video today in GNU-RADIO Companion under Windows 10. How to build your own CW receiver with a 3 filter selected. So today step-by-step guide how to build your own CW receiver with totally of 23 blocks. So let's I'll tell you about this project today. We got I put a source like Osmocom source, then going out to frequency oscillating FIR filter, then going to complex to float, then going to multiply. This is the basic of this diagram. Then multiply, we need to going to add, and then going to 3 pass band pass filters, then going to selector, and then going to AGC, and then to multiply const, and then to the audio sync. Okay, so let's fire it up GNU-RADIO Companion. Today we need to build under wxgy. So let's waiting. Let's create file in new wxgy, as you can see here. Okay, now we need to click here in this menu block in options and just rename the ID of the project like MWK CW RX. Okay, and the author, let's make it MWK. Okay, now we need to bring wxgy slider. Let's put it here. This coming by default. Let's delete this variable block. Okay, here in wxgy slider, let's label it as a frequency. So we need to make a frequency slider. The default value, let's make it 11500, because for CW band this is you can put this the default value and the minimum and the maximum as what you like. So I make the default like this. The minimum value, let's make it minus 24000, and the maximum 800,000, and the number of steps, let's make it 1000, and the style is horizontal, and this is float. Okay, as you can see here, the default value 11.5 kilohertz and the maximum 800 kilohertz. You can change these as what you like. Okay, right now we need another wxgy slider. Let's bring another one and put it here. Okay, let's label it as a audio gain. Audio gain. The default value, let's make it 0.01, and the minimum is 0, and the maximum is 1, and the number of steps 100, style is horizontal and the float. Okay, now we need to bring a wxgy chooser. So let's bring it, chooser. Okay, let's put it here. In here, just type the label filter CW. I name it like this. In the wxgy chooser, the default value, let's make it 0, and the choices from 012. Let's make it 0, 1, 2. Okay, like this, and it's labeled in 0 when you choose the filter, because we need to put 3 blocks of band pass filters. Just follow me step by step. Take these 3 blocks of band pass filter, then go into selector. So now in wxgy chooser, let's label it like the chooser number 1 is 900, and then comma the number 2 500, and number 3 is 200. This is the filter's name, choices and labels that I want to build. Okay, the type here, let's make radio buttons, and the style horizontal. Okay, as you can see here, the choices 0, 1, 2, the labels like this. Okay, now we need to bring a variable. Let's bring a variable block. Let's put it here, and let's define it as a sample rate. So this block for sample rate, so let's define it as a sample rate, and the value, let's make it 48 kilo. Okay, I'm sorry, 48000. So let's the value here is 48 kilo. Okay, now we need to bring RTL as our source. Let's put it here. Okay, let's make it very easy to show here in the screen. Okay, here blah 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 sample rate. Let's make the channel 0 frequency. Let's make it variable slider 0. From here, the ID of the wxgy slider, the first slider we make here, as you can see, for frequency. So when you move this slider on this block, so it should be change the frequency here in RTL SDR source. So let's link the RTL SDR source to wxgy slider by put the channel 0 frequency. Just put a variable slider 0 here, the ID. So let's put that ID variable okay, slider 0. Okay, and the frequency correction is 0, blah blah blah. Okay, now I think everything is good. The sample rate is sample rate, and the channel 0 frequency is variable slider. Okay, as you can see, the channel 0 frequency it's changed to this default value here from wxgy slider, 11.5 kilohertz. So the channel 0 frequency in hertz, it's 11.5 kilo. Okay, I see now everything is good. So let's bring a wxgy waterfall sync to connect to RTL SDR source. So let's bring a wxgy waterfall sync. Okay, let's put it here. Okay, here in waterfall sync, let's title it as a MWK, as what we like. I title it like this: MWK CW receiver, and the sample rate, let's change it to the 48000, and the baseband frequency, let's make it variable slider 0. So it will show in the waterfall the variable slider 0 baseband frequency. So let's put a variable, this ID, variable slider 0. That the main wxgy slider, the main block we defined in the first of the video. Here, this is free for the frequency. Okay, the dynamic range is 100 and blah blah. Reference level is 0 and the reference scale is 2.0. Okay, I see now everything is good. It's frequency set var name. Let's change it to variable slider 0. Variable slider 0. Okay. Okay, as you can see, the sample rate now is changed to 48 and the baseband frequency the same, wxgy slider. Okay, now let's connect from RTL source output here to the wxgy waterfall sync. Okay, everything is good. Now we need to bring a frequency oscillating FIR filter block. So let's bring it. Frequency oscillating FIR filter. Okay, make sure the type is complex tabs, CCC. The decimation is 1 and the tabs here, let's type this formula in tabs. This type FIR DES dot low, this underscore pass, it's open 1, 48,000, 500, 50 and close it. As you can see here, this formula FIR DES dot low. Okay, FIR DES dot low underscore pass. We open this and 1, 48,000, 500, 50 and then close like this. As you can see, like this. Okay, the center frequency, let's make it a variable slider 0. Okay, the sample rate, let's make it 48000 and click OK. As you can see on the tabs here, blah blah blah, the center frequency is 11.5 and the sample rate is 48. Okay, now let's connect it from the RTL source output to the FIR frequency oscillating FIR filter like this. Okay, now we need to bring a complex to float block. So let's bring it complex to float block. Let's put it here. I think here is good. Okay, now let's connect it from the frequency exciting FIR filter output to the complex to float. We open this block and the vector length is 1. Everything is good. Okay, now we need to bring a signal source block. So let's bring a signal source. Let's put it here. Okay, make sure the output type is float. As you can see, because it's in float, the output, the input, I'm sorry, and the output, as you can see here, it's a blue. We need to make it, when you change it to the float, as you can see, now it's going to orange. So you can connect here together. You can't connect like this from here to here because it's different protocol. So this make sure it's a float here, and the sample rate, let's make it for 8000, and the waveform, let's make it sine, and the frequency, let's make it 700, and the offset is 0. Okay. Okay, now let's connect it from the complex to float here, from the output of the signal source to the complex to float. Okay, we connect it after we make a multiply. Okay, no problem. Let's bring a signal source here, another signal source to put here up. Okay, make sure it's a float, and the sample rate is for 8000, and the waveform is cosine, and the frequency is 700, and you click OK. Okay, now we need to bring a multiply. After multiply, I will connect the signal source all together, so no problem. Let's bring a multiply block. Multiply. Let's put the first multiply here. Okay. Let's make sure it's a float, and the number of input 2 and the output is 1. Okay. Now we need to bring another multiply. Let's put it here, and make sure it's a float, and the number of input 2 and the vector length is 1. Okay, now let's connect it from the signal source output to the multiply in, as you can see here. Now let's flip the signal source. Let's rotate counterclockwise, another rotate counterclockwise. So let's make the flow graph is easy to see. Okay, now from complex to float to the multiply in, and another complex to float to the multiply in, and the signal source here to the multiply in, as you can see here. Let's make all this close together like this here. Okay, now I think everything looks good. Now we need to bring add a block. So let's put this add a block here, and make sure make the IO type to the float, and number of input 2 and the vector length is 1. Okay, now from the multiply output to the add in, another one from the multiply output to the add in. Okay, now let's bring a band pass filter block. Band pass filter block number 1. Let's put it here. Okay. Here make sure it's float to float decimating. as we can see here, float in band pass filter. Let's delete this band pass filter. Make sure it's float real tabs decimation, float real tabs decimation, and the decimation is 1 and the gain is 1 and the sample rate 48000 and the low cut-off frequency is 300 and the high cut-off frequency, let's make it 1100 and the transition width, let's make it 100. Okay, this is a band pass filter number 1. We want to make a 3 band pass filter that's selected. Okay, now I see everything's is good. Now let's bring another band pass filter and put it here. And make sure it's a float real tabs decimation, and the decimation is 1 and 1. The sample rate 48000 and the low cut-off frequency, let's make it 450 and the high cut-off frequency, let's make it 950 and the transition width, let's make it 100. Okay, now let's bring another band pass filter. Let's put it here. Now here the FIR tabs is float real tabs decimation, and decimation one again, one is the sample rate is 48000 and low cut-off frequency is 600 and the high cut-off frequency is 800 and the transition width, let's make it 50. Okay, as you can see here, the low cut-off frequency here in low pass filter block 3 is 600 and here the low cut-off frequency 450 and here the low cut-off frequency 1.1 kilo, as you can see. Now let's connect from the add output to the in here, and from the add output to the in here, and from here to here, as we can see. Now the 3 is connected. Okay, now we need to bring a selector block here to pass all band pass filter to that in the selector, to mixing it in the selector. So let's bring a selector block. Let's put it here. Okay, here in the selector block, number of inputs, let's change it to the 3 and the number of output, let's make it 1 and the type, let's make it float, and the input index, let's make it a variable chooser 0. Variable chooser 0 from wxgy chooser, from this block, from here, from this block chooser, we choose it from 0, 1, 2. So let's the input index, we should make the ID of the wxgy chooser that we type here, variable chooser 0, that we build, and that we make a choices and we make a label. So we need to link the selector to this by the ID of that. So let's put the ID here. So let's put a variable chooser 0 and the output index is 0 and vector length is 1. Let's click OK. As you can see here, 3 input 1 output. So let's connect bandpass filter number 1 to here, and the bandpass filter number 2 to here, and the number 3 to here. As you can see, right now everything is good, looks good. So now we need to bring AGC2 block. So let's bring it AGC2 block. Let's put it here. Okay, let's make sure it's a float, and the attack rate, let's make it 1E minus 3, and the display rate 1E minus 2, and the reference is 1, and again is 1, and this everything now it's good. As you can see, attack rate is 1M, and display rate 10M, and the reference is 1, and again is 1. Okay, now let's connect from selector output to the AGC2 input. Okay, now let's flip the block to make the lines easy to see. Rotate counterclockwise, another rotate counterclockwise. Now maybe it looks better now. Okay, now we need to bring a multiply const block. So let's bring a multiply const block. Let's put it here. Okay, now in multiply const, make sure the IO type is a float, and the constant, let's make it a variable slider 1, because the audio gain ID is variable slider 1. As you can see here, the audio gain from the wxgy slider block is variable slider 1. So we need to link this to the multiply const. So let's make the constant this ID variable slider 1. So let's make the constant is variable slider 1. Now click OK. Okay, now from the AGC output to the multiply const n. Let's look nice here. Okay, now we need the audio sync block. Audio sync block. The audio sync, let's put it here. Now let's flip this block to make the input from the right side. So rotate counterclockwise, another rotate counterclockwise. So now double click in this block, and let's put the sample rate here is 48 kilohertz, and the number of input is changed to 2. As you can see, now from the multiply const to input 1, another one to the input number 2. As you can see, as you can see here, I'm sorry. Now we need to bring a rational reassembler block to connect to the selector. So let's bring a rational reassembler. Okay, rational reassembler, let's put it here. Let's double click on it, make sure it's float real tabs, FFR, and the enter population is 1 and the decimation, let's make it 8. Okay. Okay, now we need to the input from the right side, so let's rotate counterclockwise, another rotate counterclockwise to manage the flow, to make it easy to see. Now from the selector output to the rational reassembler input, as you can see here. Let's make it more easy to see. As you can see, okay, finally we need a wxgy FFT sync. So let's bring a wxgy FFT sync. Let's put it here. Okay, here let's make it bigger, clear to see. The title, I don't need this title. The sample rate, let's make it 6000, and the baseband frequency, let's make it variable slider 0. Here this block that we defined the first of the video, the baseband frequency, let's put that ID is variable slider variable slider 0. Okay, and everything, FFT size is good, and peak hold is off. Okay, make sure the type is float. Okay, now let's put the input in the right side, rotate counterclockwise, another counterclockwise. So let's from the rational reassembler output to the wxgy FFT sync input. Okay, finally, as you can see here, this simple diagram here appearing, as you can see. So let's save this project to the desktop, like CW test GRC file in desktop. Now let's bring let's create the Python by clicking here to generate the flow graph. Now let's try to run this software. I don't have a high frequency or external antenna for CW reception. I just hooked my dongle for testing just how the software looks like. But I think it's very good software with the 3 band pass filters we built. Try to hook to your supported high frequency range dongle and external high frequency antenna, and give us a feedback of your reception in your QTH. So I use a stick my stock indoor antenna. So let's try to start fire up our build. As you can see here, I want to increase the volume. As you can see here, the volume of the CW filter in 900. Let's choose the 500. I think it's the filter chooser, the bandpass filters and the wxgy chooser we make is works correctly. Let's try 200. as you can see, as you can hear. Maybe it's working. Let's try 500, and let's try 900. Let's make to change the frequency, auto scale. Okay, I see now everything is works as expected. Okay, now just build your own CW program receiver and try to receive, to hook to your equipment, your dongles, and see what's going on, and try to receive the CW band in your QTH. And the frequency here, you can put any CW band in what you like here to testing. Okay, for that, this is Kanfer here, and thank you for watching my tutorials today, and stay tuned for another video tutorials how to build your own software using a GNU-RADIO companion under Windows 10. Okay, for that 73, and bye bye.